Hello, algebra students. It's Mrs. Thompson. We're in Chapter 9, Example 2, so 9.2, Example 2, and we are talking about exponential functions. We just learned how to evaluate an exponential function, and so we plugged in a number for our x. We used our calculator to calculate a population or a dollar amount. It could be just about anything. So in example 2, now we're going to focus on identifying an exponential function. So I wanted you to remember a couple of things and draw your attention up to the top of your page. Remember, linear functions have a common first difference or a common difference. You're going to add to get to the next number in your y, okay? I don't know if you remember that or not. So if we had an exponent or a linear function where we're doing 0, 1, 2, and we are doing 2, 3, 4, notice that 2 to 3 we're adding 1, 3 to 4 we're adding 1. That's a common difference. That means that if I graph those 3 points, they would all lie on the same line. So this would become a straight line, okay? So a quadratic, remember, has a common second difference. So you're going to notice all the numbers when you check your y and you're like, hey, all the numbers I'm adding to get to the next number, they're all different. But when you do it again and get a common second difference, then you're going to end up with a quadratic, some sort of a parabola, okay? Now exponential, we just learned, have a common ratio. So the x's are increasing by a constant amount, not necessarily in a multiplicative way. You're gonna add the same increment to get to your next x. It's where the y, this is what I want you to focus on. The y's are being multiplied by a constant amount, okay? So let's look at example 2. We're going to identify whether we have an exponential or not, okay? So sometimes you're going to get an ordered pair, just a list of ordered pairs. So we know it's a relation. We just don't know if it's a function. To tell if it's a function, remember the x's cannot repeat. The y's can repeat all day long, x's cannot. And all the x's are different. In letter A, we have -1 for the first x, 0 for the second x, +1 for the third x, +2 for the fourth x. All those numbers are different. This is a function of some sort. Now we're trying to determine, hey, is it exponential? So if it's exponential, when I figure out how do I get from 1.5 to 3, what do I multiply times 1.5 to get to 3? Now, if that's not coming to you easily, you're like, I have no idea. I can't see that number in my head. Well, here's how you figure it out. Take the 3 and divide it by 1.5. You're going to get 2. So that means if I take 1.5 and multiply by 2, I'm going to get 3. And that's how I figure that out. I'll do 3 divided by 1.5 in my calculator, and I will figure out, what is that number? It's 2. That means 1.5 times 2 is 3. So here it gets a little easier. 3 times what is 6? That's 2. 6 times what is 12? That's 2 again. So you see, it's all common. This is definitely exponential, okay? So again, if some of these are going to be easy, you can do them mentally, but some of the ones you're like, I have no idea. Take the second number, divide it by the first number, like I did here, 3 divided by 1.5. That's going to give you 2, and that's a great starting spot, okay? Let's look at letter B. Notice that the x's are all different, okay? So this is clearly a function. We're going up, we're adding 2 each time to get to the next one, so we're going up constantly. The y's, let's take a look. -9 times -1 would give us +9. But that's not true this time. 9 times 3 is 27. And I don't know what 27 times what is 45, so I just go to my calculator, go 45 divided by 27, and it's 1.6 repeating. See how they're all different? This is not exponential. There's no common ratio. That's your explanation. So the way you explain it is you either tell that there's a common ratio or you explain that there is no common ratio. That's how you explain whether it is or is not exponential. Okay? So we go to letter C and we look at that and we go, okay, all the x's, okay, they're all different, so it's definitely a function. We're going up by 1 each time on the x's, so it's constantly going up. So now we look at this and we go, okay, 1 times what is 0? Well, that would be 0. And then 0 times what is 1? Nothing. So this is not exponential. I can already tell right here that 0 times 0 is not 1. It's not going to work. The other clue I have to tell that it's not exponential is 0, 0. Exponential functions that are not translated, in other words, they're not going to cross 0, 0. So a typical problem like this, a times b to the x, will never cross the x-axis. Now, if I had one that looked like this, where I'd had a times b to the x plus a 1, or minus a 1, or plus 2, or minus 2, where it looks like the whole thing's translated up, or it can be translated down. Now, that can cross the x-axis, but that's not what's going on here, okay? That's clearly not what's going on here. So this is not exponential. I don't have a common ratio. And here's my other clue. It's crossing 0, 0, and exponential functions typically do not. They can if they're translated like I showed you up here, okay? Now I'm going to leave letter D for you. You try that. I'll let that be your extra credit. Is that function exponential? Let me know. Remind me, please, in class that I said that that's extra credit. All right? Thank you for listening.